Now we can discuss about the gravitational force. What is the gravitational force? Gravitational force is a attractional force. For example, I am taking two masses. Mass of the object is m1 and mass of another object it is m2. And from center of the first object to center of the second object distance is r. Center of the first object to center of the second object is distance is r. Now the gravitational force is directly proportional to product of their masses and gravitational force is inversely proportional to square distance between them. Gravitational force is inversely proportional to square distance between them. And from equation 2 you can write F is directly proportional to m1 m2 and inversely proportional to r square. When I remove the proportionality, one constant takes place, that is the gravitational constant. So G is the gravitational constant. Capital G is gravitational constant. Here G value is 6.67 into 10 to the power of minus 11. What are the units of the G? G units means we have to take, if you want to find out G units, capital G is equal to, I am taking here, okay, for your understanding, F is equal to G m1 m2 by r square. R square I am taking this side, Fr square, m1 m2 comes to denominator, that is equal to G. F unit, force unit is the Newton, distance unit is meter square, here square is there, and mass unit is kg, another mass kg, so kg into kg square. So gravitational constant units are Newton meter square per kg square. Gravitational constant units are Newton meter square per kg square. Okay, what is the dimensional formula? It is a scalar quantity. And the dimensional formula for this one, Newton means kg meter per second square into meter square divided by kg square. I am writing dimensional formula. How we are writing? Newton is nothing but a kg meter per second square, meter square as usual, kg square. This kg square, kg get cancelled. Here meter square, meter is there. So kg 1 it is there. Kg to the power of minus 1, meter square meter cube, s to the power of minus 2. So mass, how much? Kg minus 1, length meter. So 3 power it is raised how many times? Time it is raised minus 2. So this is the dimensional formula for the gravitational constant, isn't it? Again, this gravitational force is independent of the medium and gravitational force is the weak force. Weak force means, I told you gravitational force is the attractional force. Myself and board also some attractional force is there. But I am unable to experience that attractional force, that is gravitational force, that is a weak force. So gravitational force is the weak force and it is the central force, center of the object to center of the object, isn't it? And gravitational force is directly proportional to product of two masses, inversely proportional to square distance between them, and according to the equation 1, equation 2 we can write equation 3. And from when I remove the proportionality, one constant takes place, that is the G. G is nothing but a gravitational constant. Here gravitational constant unit is constant value is 6.67 into 10 to the power of minus 11. F is equal to G m1 m2 divided by r square. But G units, if I want to write this quantity, I am taking left hand side. So G is equal to these quantities. Force unit is Newton, distance unit is meter, mass unit is kg. Here kg 2 times are there. So that's why kg square I have written. It is a scalar quantity. Newton is nothing but a kg meter per second square. This is meter square as usual, kg square. here get cancelled, remaining rest. This one I have written as in terms of the dimensional formula. Dimensional formula, m to the power of minus 1, L to the power of 3, T to the power of minus 2. Okay. Then gravitational force, it obeys the Newton's third law also. Gravitational force, it obeys the Newton's third law. Newton's third law means how it is obeys the Newton's third law. Just we have to prove it. We have to prove the Newton's third law. For example, this is mass m1 and this is mass m2, mass m1, mass m2. The distance, it is nothing but a r. Distance is nothing but a r. Okay, see here, force acting on the m2 due to the m1, force acting on the second body due to the first one. Force, I am writing here for your clarification, force acting on m2 due to m1. So force acting on the second one due to the first one is equal to G m1 m2 divided by distance from here to here. I am writing as a r12. This is from here to here. I am writing as a r12. r12 whole square. Is it? But r12, it is the magnitude. It is not having the direction. This is scalar quantity. So r12, within the bracket I am writing r12 is equal to r. If I want to write this one in terms of the vector notation, F21 bar is equal to G m1 m2 divided by r12. R12 what I am writing? R square, but R12 unit vector. That is a unit vector. In the vector notation we can write like this. Second one, force acting on m1 due to m2. Force acting on m1 due to m2. Force acting on m1 due to the m2. That I am writing as a F12. Force acting on the first body due to the second body. That is equal to G m1 m2 divided by distance from here to here. Second body to first body. R21. Second body to first body. R21 whole square. In the scalar notation I have written. Same in the vector notation, if I want to write force acting on the first body due to the second one is equal to G m1 m2 divided by R21. It is also scalar only, so that's why I am mentioning it is R square. R21 vector. Force acting on the first body due to the second one means like this, from second body to first body R21. See here, distance R12 is equal to R21. From here to here distance, both are same. But in the vector notation, if I mention that is negative vector will come. Negative vector means magnitude is same but direction is negative. Magnitude is same but direction is same. See here, from here to here distance is R12. From here to here distance is R21. Magnitude is same but direction is different. So for that purpose I am writing R21 cap is equal to minus R12 cap. R21 is equal to minus R12 cap because direction is different, magnitude is same. Now substitute this one, it is here F12 bar is equal to G m1 m2 divided by R square. R21 is equal to minus R12. See here, G m1 m2 divided by R square R12. That is equal to how much you can write? F21. So F21 is equal, F12 is equal to minus F21. Equal and opposite. What is Newton's third law? For every action there is a equal and opposite reaction. So equal and opposite forces are acting. See, once again I am telling Newton's third law. It obeys the Newton's third law. How it is obeys the Newton's third law means, again I am telling you once again, two objects. Mass of the first object is m1, mass of the second object is m2. The distance between these two is r. Now, force acting on the second body due to the first body. Force acting on the second body due to the first body, that F21 is equal to G m1 m2 divided by r1. From here to here distance I taken. R12, it is a scalar notation, that is r. In the vector notation, if I want to write this one, F21 is equal to, just I have written this is bar and here R12 cap. This is unit vector. In terms of the unit vector I mentioned. Next, force acting on the M1. Force acting on M1 due to the M2. That is F12 is equal to G M1 M2 divided by, from here to here distance I am taking, R21. From second body to first body to 1 whole square. In the vector notation, here R21 cap I given, but we know R12 is equal to, from here to here R12, from here to here R21. It is scalar, magnitude is same, but when I given the vector notation, magnitude is same but direction is different. This is 1 to 2, this is 2 to 1. Magnitude is different. So that's why only R21 is equal to minus R12. Here I substituted this one. So this value is nothing but a, see here, this total value is belongs to the, here, these two are same. These two are same. So this one is nothing but F21. Instead of this one I have written F minus F21. F12 is equal to minus F21. So gravitational force is independent of the medium. Gravitational force is weak force. Gravitational force is obeys the Newton's third law, isn't it? And gravitational force is the nearly 10 to the power of 36 times weaker than the electrostatic force. It is a central force and also it is the central force. This is about the gravitational field. Okay. Now we are going to discuss about the gravity on the surface of the earth. Gravity on the surface of the earth. Now I am telling you very clearly here, if you observe the diagram, this is earth. It is earth. Center of the earth, it is point O. Radius of the earth, it is R. Center of the earth, it is O. Radius of the earth, it is R, isn't it? And take mass of the earth. Mass of earth is equal to M. Radius of earth is equal to R. I am taking a small object on the surface of the earth. Just I have taken a small object on the surface of the earth. So mass of an object is equal to small m. Okay. We can observe from center. We know very clearly gravitational force is central force. When gravitational force is central force means we have to calculate distance from center of the first object to center of the second object. Center of the first object to center of the second object. Means from this center to this center, from here to here we have to calculate. But when you compare the radius of the earth and radius of the object, if I compare, this is very very small. For example, if I keep this marker only on the surface of the earth, radius of the earth is nothing but a 6,400 kilometers. Radius of the earth, it is nothing but a 6,400 kilometer. But what about the radius of the marker? 1 centimeter nearly. 1 centimeter, less than 1 centimeter. So 6,400 kilometer plus 1 centimeter. So 1 centimeter can be negligible or not at that moment. That's why only from here to here distance also I am considering that is nothing but a r. Okay. Gravitational force is always attractional force. It is only attractional force. It is not a repulsion force. The gravitational force cap G. What is the formula? F is equal to G into m1 m2 divided by gravitational force formula. I am writing G m1 m2 divided by r square. I am writing here m1 is nothing but a mass of the earth. Mass of the earth, it is the capital M, and mass of the object is small m divided by distance from here to here. What I am writing? R. So it is the r square. Gravitational force, attractional force, F is equal to G m m divided by r square. Here F is equal to, I am writing as a weight of the object, m, G is equal to G capital M small m divided by r square. Here mass of the object get cancelled both sides. At that moment G is equal to G capital M divided by r square. Gravity on the surface of the earth, gravity on the surface of the earth, G is equal to Gm by r square. Gravity on the surface of the earth, Gm divided by r square. How we are writing means, mass of the earth, it is m, radius of the earth, it is r. Mass of an object, small m, is placed on the surface of the earth. So what is the gravity acting on this block or body? That is, first I am writing gravitational attractional force formula. F is equal to G mm by r square. M is mass of the earth, small m is mass of the object. F is equal to weight of the object. Both side mass get cancelled. G is equal to, we can get Gm by r square. G is equal to, we can get Gm by r square. This equation we can write in terms of the density also. This equation we can write in terms of the density. How we can write? In terms of the density. I am writing it is in terms of the density. So G is equal to G. What about in terms of the density? Mass is equal to, in terms of the density, if I want to write, mass is equal to, what you can write? Mass is equal to density into volume. So m is equal to density volume. Volume of the object, it is a spherical shape, 4 by 3 pi r cube. So gravity on the surface of the earth, G capital M divided by r square. G, m is equal to density into 4 by 3 pi r cube divided by r square. R square and r cube get cancelled. G is equal to G rho 4 by 3 pi r. In terms of the density, G with altitude means while you are going away from the surface of the earth, what about the gravity? Increases or decreases? That we have to calculate now. So obviously, while you are going away from the surface of the earth, gravity is decreasing. Gravity decreases. So how it is decreasing? By the mathematical equation we can prove that one. First one, I am taking gravity on the surface of the earth. Gravity on the surface of the earth is G is equal to, just now only we calculated, Gm divided by r square. That is equation number 1. Next, this is earth. Now the object is, mass of the object is small m. Mass of the object is small m. From here to here distance is, this is height h, this is radius r. So total distance is, how we can write, r plus h. From center to here, total distance is r plus h. So object I taken at certain height from the surface of the earth. At that moment, gh is equal to capital G, capital M. From this one, total distance how much from here to here? R plus h whole square. That is equation number 2. See here, one object is on the surface of the earth. For your understanding, I am writing. When it is on the surface of the earth, this is the formula. When object is at certain height, from the surface of the earth, that is gh is equal to gm divided by r plus h whole square. Now equation 2 divided by equation 1. gh divided by g is equal to gh divided by g is equal to gm divided by r plus h whole square whole divided by gm divided by r square. Both side gm get cancelled. R square I am taking into the numerator. So gh divided by g is equal to r square divided by r plus h whole square. That is r plus h whole square. See here square whole square is there, here whole square is there. For our understanding, just I am writing total, it is nothing but a whole square. R square divided by r plus h whole square. Now I am interchanging. This denominator I am writing as a numerator. Numerator I am writing as a denominator. At that moment, gh divided by g is equal to r plus h divided by r minus 2. When I interchange these two, power will become as a minus. So that's why power will become as a minus. gh divided by g is equal to, this one I am writing as a r by r plus h by r to the power of minus 2. R by r, h by r. So gh by g is equal to 1 plus h by r to the power of minus 2. Here I am applying binomial theorem. Binomial theorem, 1 plus x to the power of n is equal to 1 plus nx and so on. Higher order terms are neglected. We are neglecting higher order terms, we don't need. Otherwise, you have to remember very simply, when we are applying the binomial theorem in our physics, the power we can write here. No need of remember of this one. Just the power you can write in front of this one. See here also power they have written nx, 1 plus nx they have written. Here also I am writing power it here. gh divided by g is equal to 1. Here minus is there, plus into minus, minus 2h by r. So gh is equal to g into 1 minus 2h by r. See here, gh is equal to g into 1 minus 2h by r. Okay, listen once again. While you are going away from the surface of the earth, at that moment gravity will be what happened? Gravity decreases or increases, otherwise remains constant. Gravity decreases. By mathematical equation we can prove that one. How it is means, gravity on the surface of the earth, when object is on the surface of the earth, this is the equation. When gravity at certain height from the surface of the earth, total distance is r plus h. So gm divided by r is nothing but a r plus h whole square. Equation 2 divided by equation 1, gm get cancelled, we got like this. I interchange these two. When I interchange these two, power will become as a minus r by r, h plus r, h by r, 1 plus h by r. I applied the binomial theorem, we got like this. See here, denominator is more. What about the g value? Numerator can be decreased on it, it is inversely proportional. R is more, gravity is less. So while you are going away from the surface of the earth, gravity decreases. While you are going away from the surface of the earth, gravity decreases. So gravity decreases. Now variation of the G with depth. So while you are going to depth of the earth, what about the gravity? Decreases, increases, or remains constant? It is also, while you are going to depth of the earth, gravity decreases. In both the cases, while you are going to away from the surface of earth or depth of the earth, in both the cases, gravity decreases. This one also we can derive the equation or we can prove by mathematically. How it is means, first we have to know it. Gravity on the surface of earth. First I am writing gravity on the surface of earth. G is equal to Gm divided by r square. Mass we can write as a density into volume. Volume of the sphere 4 by 3 pi r cube whole divided by r square. This get cancelled. So gravity on the surface of earth 4 by 3 pi g rho r. This one we already derived the equation in terms of the gravity on the surface of the earth, in terms of density. In terms of the density we already derived this equation. Now this is radius of the earth. Now the object position is here at a depth d. Now the object position is at a depth d from surface of the earth. At that time, what about this distance? This total distance is r. This distance is d. So we have to calculate this region only. This region means from here to here we have to find out. That is nothing but a r minus d. Radius is nothing but a r. This distance is d. So remaining distance r minus d. Gravity at a depth. Gravity at depth d is Gd. So Gd is equal to, according to this equation 1, 4 by 3 pi g rho. Here r is nothing but this distance, r minus d. That is equation number 2. So equation 2 divided by equation 1. Equation 2 divided by equation 1, we can write Gd divided by G is equal to 4 by 3 pi G rho r minus d divided by 4 by 3 pi G rho r. So here equation 2 divided by equation 1. In this one, these get cancelled. We can get Gd divided by G is equal to r minus d divided by r. This one you can write as a r by r minus d by r. So Gd by G is equal to r by r is 1, d by r. G I am taking this side. Gd is equal to G into 1 minus d by r. Gravity at a depth d. From the surface of the earth, Gd is equal to G into 1 minus d by r. For example, if the object is placed at the center, object at center of earth, at that moment, small d is equal to r only. If the object is at a depth d, this is the equation. If the object is at the center, from here to here distance is nothing but a radius. If the object is here, the distance is d. But if the object is at the center, from here to here distance is nothing but a r. So small d is equal to r. If I substitute here, GD is equal to G into 1 minus R by R, that is equal to 0. Gravity at the center of Earth, gravity at the center of Earth is equal to 0. Gravity at the center of the Earth is equal to 0. Just how we solve it once again. Gravity on the surface of the Earth, G is equal to Gm by R square. Mass I am writing as in terms of density into volume. Volume is nothing but a 4 by 3 pi r cube. We got equation 1. If the object is at a depth d, now we have to consider remaining distance from center of the object to center of object. This distance is equal to r minus d. So instead of r, I written r minus d. That is equation number 2. Equation 2 divided by starting. While you are going away from the surface of the Earth and depth of the Earth, see here, while you are going away from the surface of the Earth, depth of the Earth, gravity decreases. Gravity decreases. Mathematically, just now only we proved. What is that equations are? Gh is equal to G into 1 minus 2h by R, and one more it is GD is equal to G into 1 minus d by R. These two equations. So here above the Earth, this one only we have to show the graphical representation. Now GH is equal, before this one we use the step to derive this equation. We use this equation at the moment. See here, G R square divided by R plus H whole square. This R plus H I am writing as a small r. Now GH is inversely proportional to R square. GH is inversely proportional to R square means we can observe the graph, it is nothing but a like this. We can observe the graph, it is like this. G on the y-axis, distance on the x-axis. So G is inversely proportional to R square means it will become as a curve shape. And next one, GD. Say GD is equal to G divided by R, R minus D. R minus D I am writing as a small r. So at that moment, GD is directly proportional to R. Directly proportional to means it is a straight line. So the straight line from here to here it is inside, from here to here it is outside. So this is the graphical representation of the gravity, variation of the gravity. Now variation of the G with the latitude means, see here, this is the axis, it is Earth. We can see, I am taking this is the equator, this is equator, and this one it is the pole, and it is rotating like this, isn't it? Now from equator to pole, while you are going from equator to pole, what is the gravity? While you are going from equator to pole, what is the gravity? It increases or decreases. While you are going from equator to pole, the gravity can be increases. How it is means, for example, the particle position is here. The particle position is here at point B. It is a one particle or one object. Position is at point B, and from the center to, and this is capital R radius. We can take. It is making an angle with the equator. It is the pi. This is making an angle. It is the pi. This is the pi, and from axis to the particle it is. See here, this is the particle position and this is axis. From particle position to axis, this distance is the r, small r. Now the centripetal force acting on the particle it is along this direction. The centripetal force is acting along this direction. See here, now the particle it is at point P position. The particle position is at point P. From center of the earth to particle position it is, that is radius r. And the centripetal force is acting on the particle, that is along this direction. From here to axis, rotation of the axis distance is the small r. At that moment, this centripetal force is making an angle with this line, it is the pi. Centripetal force is resolved into the two components. One it is horizontal component F cos pi, and vertical component is F c sin pi. Here there is no effect of the vertical component. Now the weight of the object, it is particle, it is acting towards the center along this direction, that is mg. Here F See, cos phi it is acting upward direction, mg is acting downward direction. So at that moment I am writing it is mg dash resultant force is equal to mg minus fc cos phi. See here, resultant force is equal to mg dash is equal to mg minus fc cos phi, and here mg dash is equal to mg into centripetal force. What is the formula? mr omega square cos phi. Yes, centripetal force is nothing but a mr omega square. I am writing here centripetal force fc is equal to mv square by r, that is equal to mr omega square. The centripetal force formula mv square by r, and the otherwise mr omega square. That only I write. But what is the smaller value? The smaller is equal to what you can write means this is phi. If I write it, cos phi is equal to, from the diagram, cos phi is equal to adjacent side by hypotenuse. Adjacent side by hypotenuse. Adjacent side it is smaller, hypotenuse is r, capital R. So smaller is equal to capital R cos phi. Substitute in this equation, equation 1, equation 2. So substitute equation 2 in equation 1. At that moment mg dash is equal to mg minus m, r is equal to r cos phi. R cos phi omega square cos phi. So you can write both mass, if I take common, get cancelled. G dash is equal to g minus r, I am writing omega square cos phi, that is cos square phi. So this is g dash is equal to gravity at a point P. Gravity at the point P, position g dash is equal to g minus r omega square cos phi. For example, this particle position is at point A. The particle position is at A. At A means that is nothing but a equator. That is at equator. Equator means what about angle it is here? This is equator, the particle position is here. If I am taking the particle position is here, what about the angle? It is 0. So phi is equal to, I can write it is 0 means g dash is equal to g minus r omega square. Cos 0 is 1. Okay. Then next one, pole. At this point I am writing as a B. At B. At B means, see here, this is equator and this is point B. What about the angle? It is 90 degrees. Phi is equal to 90 degrees. So when phi is equal to 90 degrees, g dash is equal to g minus r omega square cos square 90, that is equal to 0. So here g dash is equal to g minus r omega square. Here g dash is equal to g minus 0, that is equal to 0. See here, r omega square value subtracted from the g. So this value decreasing, but here g only it is here. So when object is at point A on the equator line, gravity is less. When object is on the pole, gravity is more. At that moment, so gravity at pole it is greater than gravity at equator. Gravity at pole is greater than gravity at equator. And also weight also. For example, weight at pole is greater than weight at equator. Weight at pole greater than weight at equator. Okay. Once again, then object is, this is axis of the pole. Axis, this line we can represent as a pole, and this is the equator, and it is a rotation of the earth like this. I am taking west to east direction. When it is rotating, west to east direction while it is rotating. Now the particle is here. From center to particle distance is nothing but a r. Centripetal force is Fc acting along this direction. This Fc is, now how we can just, I want to conclude this one. This is equator and it is pole. The earth rotation, it is west to east direction. Like this it is rotating. So this is axis of rotation we can take it. I have given the symbol also very clearly. Once again I am telling this is equator and it is pole. Now the particle position is here at point P. Point P to center of the earth, this is nothing but a radius r. The centripetal force is acting along this direction. Centripetal force is resolved into two components, Fc cos phi and Fc sin phi. Horizontal component along this direction. Fc sin phi does not affect the rotation. Weight is acting towards the center. So mg is acting downward direction. Fc cos phi is acting upward direction. Resultant force is equal to downward force minus upward force. Here Fc centripetal force is equal to, I am writing mr omega square. Here cos phi smaller is equal to, from here to here distance, axis of rotation to point P distance smaller. This r value how we can calculate means cos phi is equal to adjacent side by hypotenuse. Adjacent side is smaller, hypotenuse is capital R. Smaller divided by capital R. R if I take in this side, smaller is equal to r cos phi. Equation 2, I substituted in equation 1. I got this one. So g dash is equal to g minus r omega square cos square phi. At equator, when the point P is here, means when the point P is here, this is equator line. Now at that time angle it is phi. But when point P is here, what about angle is 0. So cos 0, 1. I got this one. When point P is at pole, like this, at that moment angle is 90 degrees. Cos 90 is 0. So this part is 0. G dash is equal to G minus 0. G dash is equal to G minus 0. That is equal to G. That is equal to G. I got it. So here gravity at pole is greater than gravity at equator. Weight at pole is greater than weight at equator.